Numbers 1 through 5 are calculator inactive. In this review of Math 1 Polynomials and Quadratics Test Part 2, we're going to review all of the topics that will be on this test. Number 1, which equation best models the function graphed? What we can do here is identify the zeros or the x-intercepts from each of these equations and see which of them matches this graph. So we have these two x-intercepts. They are at 2 and 4. So what we need to do is factor each of these options. So A, we have two numbers that multiply to 8 and add up to -6. So that would give us, 4 and 2, they would both need to be negative. So if we factor that, x minus 4, x minus 2, set them both equal to 0. Then solve for x. So in this one, x equals +4, x equals +2. So it just so happens that A is the one we're looking for here. Keep in mind that for the calculator inactive problems, you must show your work to receive credit for those. Number 2, what is a solution to the quadratic below? So finding solutions or x-intercepts, we're going to factor. All right, so on this one, we have a GCF. All of these numbers are divisible by 2, since our A was not 1. So now that 2 is going to come in front, and we're going to divide. So that leaves us with x squared, 6x, and -7. Now what we can do is we can factor inside the parentheses. So multiplies to be -7 and adds up to 6. That would be, 7 and 1 probably. 7 minus 1 is 6. So there are our factors. X plus 7, x minus 1. Again, it's asking us to solve, so we need to set these equal to 0. And then solve for x, so subtract 7, that'll give us -7. Add 1, that will give us x equals 1. So B is the only one that makes sense here. Again, make sure that you're showing this work to receive that credit. Number 3. Which expression is equivalent to this one? So anytime you have something raised to the second power in parentheses like this, that means that thing, 3x minus 5, times itself twice. So now we can box this. I like to use the corner here just so I can save a little bit of space. 3x minus 5, 3x minus 5. Now I'll do your multiplication. All right, and then we can combine some of these like terms, -15x and -15x. That will combine to be -30x. So we have 9x squared minus 30x plus 25. And that is D. Be careful on your signs here. Notice how closely these two are related. Number 4. What's the value of the smaller 0? Pay attention to that smaller 0. A 0 is just an x-intercept or a solution. So to find that, we need to factor again. And so to do that, we have a greatest common factor again. All of these are divisible by 2. So let's bring that in front and divide. That would be x squared, negative 5x, negative 6, and x chart this guy. Negative 6 multiplies to be negative 6, adds up to negative 5. Let's see, probably 6 and 1, but it could be 3 and 2. Let's see. Negative 6 plus 1 is negative 5. So there's our factors. Right? And then set those equal to 0. Okay, so add 6, that would give us x equals 6. Subtract 1, x equals negative 1. So the smaller 0 is negative 1. And the last calculator inactive problem. All right, the question being asked, how many seconds did the ball take to hit the ground? So if we because this is calculator inactive, all we know about this is that A is negative, so we know that this is going to look like an upside down U, because it's going to open down. We don't necessarily need that, other than to imagine that this would be the path of the ball. So we're looking for that X-intercept, right? If this is your kind of your X-axis, Y-axis, we're looking for where that would hit the ground. So we're looking for an X-intercept. And so to do that, we need to factor. Right, so let's see, negative 16. I'm going to change these to X's just for the sake of keeping things consistent. And both of these are divisible by negative 16. And they both have an X. So we can pull that out as well. So negative 16x, then in parentheses, we're going to divide. Since I have x squared and I took 1 out, this exponent is going to become a 1, and that's going to leave us with just an x. Next, a positive over a negative is a negative. 32 divided by 16 is 2, and these x's will cancel one another out. So then we set those equal to 0. Okay, so divide by negative 16, x equals 0, or add 2, x equals 2. So how many seconds did it take for the ball to hit the ground? Well, if we consider at 0 seconds, wherever the ball was, maybe it was on the ground and she kicked it up, and it hits the ground at 2 seconds. So it wouldn't hit the ground at 0 seconds. That was when she kicked it initially. So 2 seconds later it hits the ground. All right, moving on to the calculator active portion. So on these, you may use Desmos. Now, that doesn't mean that you don't have to show support. You still need to show some support, whether that is a sketch of your graph or just a brief explanation of what you were looking for. How did you come up with your answer? These aren't questions that you can just look at and tell the answer for the most part. If there is one like that, I'll let you know. Number 6, the vertex is located at 3, negative 12. The function has zeros, x-intercepts, at 1 and 5. So let's graph this because it's calculator active. Okay, let's just try out the first one. Okay, we need x-intercepts at positive 1 and positive 5. That doesn't do it. Let's try B. Okay, this one has x-intercepts that are negative, so not that one. Okay, let's try C. All right, again, I have not the x-intercepts that I need. All right, so it looks like D is the winner. So we're going to check, and here's how we would show the work for this. A sketch of the graph showing that I have these three things that I needed. So I have just kind of a sketch of what this looks like. 1 and 5 for my x-intercepts, and that vertex at 3, -12. So that's the work that you would need to show for one like this. Okay, number 7. Just factoring, nothing special about this one. You can check it, I suppose, in the calculator, or use that to your advantage if needed. Now here, I do see a GCF. Both of these are divisible by 3. So if I divide that, that would be just x squared and 25. Now, I don't see that as an answer choice. That's because we can still factor this quadratic. There are two terms. I can take the square root of both of them. So then my factors will have a plus in the middle of one and a subtraction in the other. And that matches with A. This was the method called difference of squares. Number 8. Which of these is a factor? Again, factoring. A is not equal to 1 here, and there's no GCF. I can't divide 11, 24, and 4 by anything, so we move on to slide and divide. Right, so we slide first. That results in x squared plus 24x plus 44. Then use the x chart. Okay, so that would be 22 times 2 and 22 plus 2. And don't forget to divide. Simplify. 22 divided by 2, or sorry, 22 divided by 11 is 2. The other one we can't simplify, so it's 11x plus 2. So the factor that matches here, 11x plus 2. On to page 2. Again, calculator inactive, so use that to your advantage. The question being asked here, how many seconds does it take to reach the maximum? So what we're looking at here is if it has a maximum, again, because A is negative, we know that this is going to look like an upside down U. So it's going to have a maximum at the vertex. That vertex has an x and a y value. X is going to tell you the time. y is going to tell you typically the height. We are looking for the time because it says how many seconds. So let's go back to the home screen, graph this, see what that vertex is. Okay, I have the point 2:30. So again, how many seconds does it take? It would take 2. Now, on a free response on the test, make sure that you only type in a number. You do not need to type any words or symbols other than a negative sign or a decimal if it's needed. Number 10. Joseph is comparing functions. Which statement is true? So let's graph these and look at them. Oh, where's my, there it is. All right. The first one. The second. Okay. Do they have the same y-intercepts? Yeah, actually they do. So the only work you would need to show here is maybe just a sketch of the graph. So we have one, and then we have the other, and they share that same y-intercept. We could also tell that they share the same y-intercept because their c values are the same. C is the y-intercept. And here, for both of them, it's 10. We want a function that has x-intercepts at -2 and 4. A has the wrong x-intercepts. Let's see. C has the wrong x-intercepts. B has -2 and 4. Okay. And D also has -2 and 4. All right, then we need a maximum. Maximum is going to look like an upside down U. So B is our only option. And let's check on that third criteria. Axis of symmetry, x equals 1. That's true. So B is what we're looking for here. 12. Which statement is not true? The ball's in the air for 5 seconds. That's true. That's when it hits the ground at 5 seconds. B, the ball's the same height at 1 and 3 seconds. Okay, so there's at 1 second. There it is at 3 seconds. That is the same height, 128 feet. So that's true. C, the ball reaches a maximum height at 144 feet. Yep, that's true. That's your max. Let's see about D. The ball starts at a height of 0 feet when it's thrown. No, the ball doesn't start at 0. It actually starts at 80. So D is false, and we are looking for a false statement. So there we go. For this one, the only reasoning you may need to give is it actually starts at 80. Okay. 13. A ball is thrown in the air. Let's see, what are we looking for? The initial height. Okay. So again, on this one, this is one that might not require any work, but we can still show support. The initial height is your y-intercept, and that is the c value, which is 10. So you could graph this. If you didn't remember that you could just find the c value. If you graph this, you'd be looking for the y-intercept. And I'm using x's, it looks like. They're using t's in this problem, but we're going to graph using x's. I like to keep that consistent. So here, kind of zoom out, click on your y-axis, and there it is at 10. So that's another way that you could justify your answer, is just kind of give a sketch of that. So yep, x-axis, y-axis is at 10. 14. It's asking what's the value of the larger maximum. So I can see here we're comparing two functions. So we're comparing the maximum of this one. So we need to graph this, see what this maximum is, and compare it to the maximum on this graph, which is 9. So let's graph this guy and see what it looks like. Okay, negative x squared. Okay, oops, plus 10, excuse me. All right. All right, so this graph looks like an upside down U. The max is at 19, because this is the point 319. And that y value is the maximum, so the larger one is 19. All right, next page. 15. What is the value of t when the model rocket reaches the maximum? So it's asking about the t or the x value of the vertex, because the maximum is at the vertex. So let's graph it, find the vertex, and look at the x value. Okay, vertex, again, just sketch it. So 2 seconds is what we're looking at there. All right, 16. All right, the graph of a function has a minimum. So we know if there's a minimum, it's going to look like it's facing up. Oops. We know it's going to be facing up and have a min. So we could eliminate a and b for that reason. And we need to have it on the line x equals 6. So that's our axis of symmetry, needs to go up to 6. So here it looks like D, where we have our axis of symmetry going through 6. And a minimum okay, 17. Which statement is true? It says the graph below represents this equation. So we're not comparing, it's an equation and the graph is given. Is there a y-intercept at 0, -6? Based on this graph, looks like each of these is 1. So yeah, that's true, actually. -6 is your y-intercept. So there would not be a y-intercept at 0, -2. -2 is an x-intercept. Now I want you to be kind of careful because, let me fix this here. If you're writing a point x, y, and x-intercept is a -2, 0, whereas a y-intercept is a 0, -6. because of the placement of those variables. Okay, so just pay attention to that. All right, number 18. Here we're comparing, so we've got two different ones. We're looking at the axis of symmetry. Okay, so if we graph this, you could graph it, or you could do it by hand if you wanted, but graph is a little bit safer. Just make sure you don't make any errors. Okay, so axis of symmetry, it's going to go through that x value of the vertex. So for this one, we need to sketch this graph to give some support for this answer. And let's see, it looks something like this. And this goes up through -1 is our axis of symmetry. And then we're looking at the axis of symmetry here. That goes through +1. So we're looking for what is the distance between them. So if you have something, think about your number line, right? On your number line, let's say -2, -1, 0, 1, 2, and it goes on forever. If you have one thing that's at -1 and one thing that's at +1, there are 1, 2 units between them. So that's a total distance of 2 units. That's C. All right, 19. An object is launched above the ground. Which statement is true? So what we know automatically is that 30 is the y-intercept, or the initial value. So B is correct there for that reason. And we could graph it too, just to verify. Make sure that we haven't made any silly mistakes here. All right, so now let's see. A is incorrect because the maximum here is at 66 feet. And that maximum of 66 feet is after 1.5 seconds. And so A, C, and D are incorrect for those reasons. Okay, number 20. What is the maximum height? So that's the y value of the vertex. All right, so we can graph this, find that vertex. Here we go. Give it a sketch to show some support for this answer. That vertex is at 3,144, so that means at 3 seconds it's at a maximum height of 144 feet. So if this is a free response, you would simply type in 144. You do not need to type in the word feet or FT or anything. You just need to type in the number. Last page. Given a quadratic f of x and the graph of g of x, what's the distance between the y-intercepts? Right, well, we can identify this y-intercept from g of x, and I'm going to make a note here that this is g of x. This is that graph. And this y-intercept is 8, and then we're going to have to graph this one. Actually, we don't technically have to graph it, because what do we know about a y-intercept? It's C. So technically our y-intercept is 10, but if we want to graph it, this is f of x, just to show that on the graph. Let's see, we have okay, so here we go. Just to show it, we have, it looks something like this, where this is at 10. Okay. So now what's the distance between them? So we have, again, think about your number line. Okay, so you have 7, 8, 9, oops, 10. Okay, so if you have one item on 8, one thing is at 10, how many units is that? That's 1, 2. So that's a total of 2 units. So the distance is 2. All you would need to type in on your test is 2. And last question. This time we have f of x is the graph shown below. So I'm going to label this just to keep things straight. And we have g of x here. So we're probably going to need to graph that. Yeah, so both of these are looking at the x-coordinate of the vertex from both of them. So let's go ahead and find this vertex. This is 1, 2, 3, 4, 5. So this is at 2, and this would be 1, 2, 3, 4. So this is 2, 4. Okay, and for g of x, we have, let's see, x squared plus 6x. Okay, we have this kind of graph. And we're looking for the vertex, so -3, -9. Okay, so it says let h represent the x-coordinate of the vertex of f of x. So of f of x of this one here, it says let h be the x-coordinate. Okay, so h, well, let me do a little h, keep it consistent. And then it says let j represent the x-coordinate of g of x. So of this one, j is the x-coordinate. So then it says to find the value of h minus j. So that's going to be h minus j. So that's 2 minus -3. So that's technically 2 plus 3, and that is 5. You would type in 5 and nothing more or nothing less. All right, I hope that was helpful. If you have any questions, send me an email.